All right, here we go. It's Thursday. We're going to take a concept check before we do anything else today, covering your relations versus functions. And when you get that done, I want you to sketch these three graphs in your notes because we're going to talk about a little bit more stuff about evaluating functions today and talk about homework, that kind of thing. So again, concept check, please. And when you're done with that, please turn it in at the back. Pause here until concept check is done. You'll have about 10 minutes to get that done today. Okay, so let's take a look at what your answers should have been on your concept check. So if you take a look at our given, we have 1, -3, 4, 2, 1, 0, and -5, 7. So obviously the table should have matching numbers. Here's a couple of things that you should have done. Number 1, no duplication. So there should not have been 2 1s in the map. There should be 2 lines coming from the 1 to -3, 1 to 0. If you drew duplication there with 2 1s, you're going to lose a point or two. Graph. We should have a graph kind of looking like this. Notice there is a vertical line right there, so that should have told you also that there was a problem with this relation. Domain and range. Your domain and range, the numbers should be in order. Okay, they should be in order. So I should have -5, 1, and 4 in the brackets. The range should be in the brackets, -3, 0, 2, 7 in the brackets. Okay, in the brackets. So remember, order matters in domain and range. No duplication in the map. You can duplicate in the table, you can duplicate in the graph, but you cannot duplicate in the map, and you cannot duplicate in the domain and range. And the question number 5 says, is this a function? No, it's not a function. You should have written something along the line of there's a duplicate x of 1, or there's 2 lines coming from the 1 in the map, or it doesn't pass a vertical line test. Something like that should have been stated. If you missed some of those, I want you to grab a correction sheet and work on that today. Turn it in with that homework on 1.6 tomorrow. Okay, so let's take a look at these graphs. You should have sketched kind of these graphs. You should have these 3 guys kind of drawn. We're going to make a few notes on here. So obviously, this is a linear graph. We know that this is a positive slope because it's going up. So there definitely is an increase in that one, okay? There is an increase. So as time passes, my profit increases. This is lawn mowing service. So if I was to write a general statement about what's happening in that problem, I would say something like, the more weeks pass, the more lawns I mow, so the more money I make. Something along that line. All right, let's take a look at this next one. So this one is definitely not a straight line. It is a curve, and it is going down. Okay, it is decreasing. So let's see what's happening here. So this is actually vehicle depreciation, which means, most of you know this, that when you buy a vehicle from a car dealer and you drive it off the lot, it automatically is worth less money than it was 10 minutes ago when you paid for it. Vehicles depreciate at quite a rate, pretty fast, at how fast cars go to limited, if any, value, which is why sometimes we may have a car loan of $5,000 or $6,000 left, and we total our car, and the blue book value on the car, and the insurance company is like, hey, sorry, we're only going to give you $2,000 because the car's not worth anything. So that is kind of what's happening here. So the years since purchase, and we have the value in money. So notice that we started here. So this would be how much the car was. So we paid almost $20,000 for this car. Okay, and at 12 years, which really isn't very long, the car is worth less than $5,000. Okay, less than $5,000. We think about year 4. So we've only had the car for 4 years. The car is worth half of what it was when we started. That is a significant decrease, okay? So this one happens to be called an exponential decay because it's going down. Now, obviously, this one is linear, okay? So linear, we're gonna spend the rest of the semester working on once we get through equations, and then second semester, we'll take a look at exponentials when we look at curves. All right, now let's take a look at this one. So this one goes up and then it comes down, okay? Goes up and comes down. So this one, advertising expense in the thousands and profit. So starting point, we have a y-intercept here and we have an x-intercept here, okay? And interestingly enough, this graph has a couple of interesting pieces. So I can draw a line down the center here. And this is called symmetry. So it actually has a middle or a reflection. Everything on the left matches the right. So there is an exact point here that matches on this side. Everything matches. There's an exact point, okay? So it's kind of like when you were in elementary and used to cut out hearts at Valentine's Day. You fold a piece of paper in half and you cut out that heart. That heart is a perfectly symmetrical shape. There's the center. Okay, so that's what this graph kind of looks like. So this one starts, comes up, and then goes down. So it has a maximum. Okay, it has a maximum. It has a top. So in this case, the maximum is going to be 50, maybe $55,000 is the most that they spent on advertising. Okay, and that would be giving them a greater profit. So if they spent, let me rephrase that. My middle is going to be approximately 10, okay? So when I spent $10,000 on advertising, my profit would give me a maximum of approximately $55,000. Okay, so this graph is called a quadratic, and it is going to have a power of 2. Okay, which is what's going to give us the left side and the right side. So again, math is not just straight lines. So there's lots of curves we're going to look at. This graph is definitely not linear because it's going to go up and then it's going to come down. We're going to find out that when we hit quadratics, there's going to be maximums and minimums. There's going to be context where I can't have that part of the graph. Specifically like over here, how do you have negative money? I can't. So everything has some context here. So take a minute and write down a little bit of information on your quadratic and the exponential and the linear, and then we'll move on to our lesson for today. All right, checking homework. So 20 is a yes, 21 is a no because there's double 4s. Notice how you have that double right there. 22 is a no, you have duplicates in the -5s. 23 is a yes, there's no duplication. 24 is a no, I can draw a vertical line right there. And 25 is a yes, because no matter where I draw the vertical line, I'm good. So take a second and double check your homework. Pause here. All right, let's keep going. 27 is a yes, 28 is a no, 29 is yes, 30 is no. Now let's think about this for a second. So if I have y equals 8, I want you to think about what kind of line that is. So this is my x and my y, and y equals -8. That is going to be someplace down here. Okay, so y equals -8, that is a horizontal line. So that line is going this direction. Okay, notice how there's no x's in this equation. So that means I cannot touch the x-axis. If I cannot touch the x-axis, that means I'm drawing a line through this point without touching that line. The only thing I can do is draw a horizontal line. So that one would definitely pass the vertical line test because if I drew a line, it would only touch once. Well, then if I have x equals 15, that's going to put me way over here on the x-axis. So notice how this one doesn't have a y, which means I have to draw a line through this point without touching this axis. I can't touch the y. So that graph, the only thing I can do is draw a vertical line. Well, a vertical line cannot be a function because if I was to draw a vertical line, I would be touching everywhere. Okay? So x equals, that is vertical, and y equals, that is horizontal. I want you to pause here and make sure that you make a note of that because you will see that again. Again, y equals is a horizontal line, cannot touch the x value, the x-axis, and x equals a number is a vertical line. You cannot touch the y-axis. You can only touch the x-axis. 31 is yes. 32 is yes. 33, -1. 34, -15. 35 is 2. 36 is -3. 37 is -4. 38 is -10. 39, -8y minus 3. 40, 36m squared minus 30m. We'll talk about that one here in just a second. I'll run through a couple of these. 41, -2c plus 7. And 44, 42 is -2r minus 7. 43, -10d minus 15. Hey, there's a multiplication there. We'll talk about that one. And 44, 3n squared plus 15n. So let's go ahead and take a look at a couple of these. I'm sure there were some questions. So let's start by looking at number 40. So I have g of x. So that is something squared plus 5. So I know I'm going to put in a -6m. So this one's pretty easy. That's a multiplication. That's going to give me a -30m. Now here, -6m squared, that is -6m times -6m. Well, -6 times -6, that's 36. Well, m and m, I have 2m, so that is an m squared. Okay, that is an m squared. So this is then 36m squared minus 30m. Let's take a look at 43. So 43 says that we're going to put in a d. So first of all, I know that I'm going to get an expression, not an actual number for an answer, and I have to multiply it times 5. So if I take my function and I put in a d, okay, and I simplify that, I come up with -2d minus 3. So that is the middle part. Now I know that I have to multiply this times 5. So the 5 is on the outside, so I'm going to multiply -10d minus 3. Whoops, minus 15. Almost forgot to multiply that second part. So that is equal to our function. Remember, you want to make sure and write these in function notation. 44 is almost exactly the same. The rest of these should not have been too bad. Remember that something like this one, you have to do the math on the function first and then add or subtract 7. So if I was to put in the 0, that would leave me with a -3. And then I have to subtract 7 because that piece is still on my function. That's going to give me that -10. So that is where that is coming from. Okay, if you have additional questions on your homework, feel free to take a picture of the problem you're struggling on or send me a question via email or on Schoology in a message, and I'm happy to respond to you on other things that you didn't understand. Okay, 45. I think we're going to skip this guy. We'll talk about that one when I get back. So just make a note that we'll talk about 45 when I get back in person. Okay, so composite functions. Composite functions are just a little bit more of an advanced function operation. So it kind of looks confusing because all of a sudden I have these double function, weird looking things. So this is actually read f of g of x, okay? f of g of x. So it means I'm going to use the answer from one to put into the other. This one is g of f of x. So it's just telling me you're going to take an answer from one and put it into the other and evaluate again. Okay? So it looks confusing, not a super big deal. So let's just keep with eyes up and let's look at what's happening here. There's quite a few different ways to write composite functions. You notice how this one has this little circle, kind of looks like a degree symbol. So this is actually the same as this, f of g of 3. So I'm always going to start on the inside, okay, on the inside. So the first thing I'm going to do is evaluate g of 3. So that means the g of 3, I'm going to plug into the x squared, plug in my 3, so that's going to give me 3 squared is 9. So now I actually have f of 9, okay? So now the 9 has to go into this function because that's my f function. So 3 times the 9 minus 5. 27 minus 5 is going to bring me to 22. So my f of g of 3 is actually 22. Now, this one is exactly opposite. It's g of f of 3. So that means I'm going to do the f first. So if I plug in the 3 for the f, that's 9 minus 5, which gives me 4. So now I'm here. I have to do g of 4. So again, I'm squaring when I'm doing the g, and I'm going to get 16. So g of f of 3 is equal to 16. So again, not a big deal. It looks confusing, but all it is take the answer from one and put it into the other. Take a minute, get caught up on your notes, and we'll move on. Okay, take a second and see if you can figure out these guys. Remember, this is g of f of negative 2, and you're working from the inside out. And this one is f of g of negative 2. So here you start on the f, and here you start on the g. Pause here, see if you can come up with these answers. Okay, so if I substitute into my f, that's 6 plus 4 is going to give me 10. And now I'm looking at my g, so I'm squaring the 10 squared. So g of negative 2, that's going to give me 100. Again, this one I'm starting with the g, so the first thing I'm doing is squaring. Remember, when you square something, it's positive. So now I'm looking at f of 4, so negative 3 times 4 plus 4, negative 12 plus 4, that is bringing me to 8. So you can write these either way. You can write them as composite functions with the little circle, or you can write them as nested parentheses, which this is. So hopefully you came up with 100 and you came up with 8. Okay, when we are adding and subtracting functions, or multiplying and dividing, the operations happen first. So f plus g of x is f of x plus g of x. You're going to do this one, and then add your answers. Same thing with subtraction, multiplication, and division. So order matters. The first one is the first operation. The second one is the second operation. The adding and subtracting, multiplying and dividing kind of goes in the middle, okay? So just kind of take a look at that, and we are going to look at these operations. Okay, so this one is multiplication. So it's wanting me to substitute in 1. So let's go ahead and just put in 1 for these. So 1 squared plus 4 plus 2 times 1. So that gives me 1 plus 4 plus 2. That is a 7. So for g, I got a 7. For my h, I have to substitute in 1. Negative 2 times 1 plus 2. Negative 3 plus 2 is negative 1. And what am I doing with these guys? I am multiplying. So I'm taking 7 times negative 1. My answer is negative 7. So g multiplying h of 1 is negative 7. If I substitute in a 4, and remember we're subtracting here, so we have to come up with both answers and subtract. So 4 times 4 minus 3, that's 16. 16 minus 3 is going to give me 13. If I substitute in the 4 here, 4 cubed is going to give me 64 plus 8. So 64 plus 8 is 72. So I am subtracting. So this is 13 minus 72. And if I'm subtracting 72 and 13, I know I borrow. So I am at a negative 59. So that notation could look like this, or it could look like the f minus g of 4. Go ahead and pause here and go ahead and solve the next two. See if you can come up with an answer. Compare with a neighbor when you are ready. Okay, so 3 is 8 of 10. So 3 times 10 plus 3 is going to give me 33. And g of x is negative 4 times 10 plus 1. That's going to give me negative 39. And if I'm adding them together, I know I come up with a negative 6. 8 plus g of 10 is negative 6. Substituting in a 3, 3 times 3 is 9 plus 2, there's an 11. And 2 times 3 is 6. 6 minus 4 is 2. So in this case, I have 11 divided by 2. I'm going to leave that as a fraction, and that is already reduced to lowest terms, and there's that answer. Hopefully you come up with negative 6 and 11 halves. So at this point, we're going to move to homework. And you've got some composite functions and some adding and subtracting I want you to work on. You do have a test coming up, so make sure that you are working through those. We will talk about some answers, and tomorrow is going to be kind of a busy day on Schoology, so make sure that you are caught up.